Okay, so in this problem, we're looking for the area of the shaded region, and the entire circle has a radius. Actually, we don't know what the radius is, so we're gonna have to solve for it if we need it. Arc AC is 100 degrees. Let me mark that right here, 100 degrees. Now, when we cut this up, I'm gonna connect. Oh, and the chord is 30. I'm gonna connect B to A and B to C to get a couple of radii in here. And you might be able to tell if we found the area of, most people only think of sectors as smaller regions of a circle that you form by cutting out a couple of radii here and then you get a slice of the pie. But really, this whole region, is also a slice of the pie. It's just a huge slice. So you can use the same kind of formula if you know that central angle still to get the area of everything that's left over. So what we're going to do is we're going to divvy this up into two regions. So this is region 1, and this is region 2. And you should be able to tell if I just add those two regions together, then I get the total shaded area, right? So region 1, you might notice this big arc that's left over is 360 minus 100. That's 260 degrees. So the area of region 1 is going to be the area of a sector. It's 260 over 360 times pi r squared. Well, I still need r. Okay, that's where region 2 is going to come in handy. So let me draw region 2 by itself here. So here's the triangle right there. This is 30. And then since the arc is 100, the central angle is 100. And then I'm going to chop it right down the middle. So I'm going to get 50 degrees here, 50 degrees there, 15, 15. We know these are both radii. So to get the radius, let's see, we'll use sine, because that's opposite over hypotenuse. So sine of 50 equals the opposite over the hypotenuse. And then if I multiply the r over, I get 15, and then I'll divide both sides by sine 50. And if you plug that into a calculator in degree mode, you end up with 19.5811. So the radius is 19.5811. So I'll plug that in right here. 260 over 360 times pi, 19.5811 squared. Now on a calculator, you should have this stuff stored. You're just cutting and pasting the long thing there. So this ends up being about 869.9520. Okay, so that's the area of the Pac-Man shape. Okay, so then let's look at region 2. Here's region 2. Okay, that's a triangle. So the area of region 2 is 1/2 base times height. Well, we know the base is 30. 1/2, 30 times whatever the height is. This is the height right here, right? So since we know what the radius is, 19.5811, and we know that this is 15, you could do Pythag on that triangle to get the height, which I'll call, I don't know, I'll call that x. But you could also do trig. And if we did trig, 15's opposite, x is adjacent, we could use tangent. So tan of 50 is going to be the opposite side over the adjacent side. If I multiply over the x, and then divide by tan 50, then x, the height, ends up being about 12.5865. So that's the height. That's what we plug in right here, 12.5865. And then when you work all that out, you end up with area of region 2 is about 188.7974. So then I need to add region 1 with region 2, and I've got the whole shaded region. So area of shaded equals the 869.9520 plus the 188.7974. And if you add those together, you end up with about 1058.749 if you store and then round. And then in this problem, everything was in inches. So the area is going to be in square inches, inches squared. Okay? And then we'll do the last problem in the same video here. So in this one, we got the radius is 12. So let's connect some of these radii to the corners of the square. So those are all the same. You might remember in a square, the diagonals are perpendicular to each other because the square is a rhombus too. So all these are actually right angles in the middle. And then these angles all end up getting bisected. So these are all 45s now. 45, 45. So there are lots of ways you could get the side of the square. You could do 45, 45, 90 theorem. You could do trig. You could do Pythag. So there are lots of options for getting the side of the square. Ugh, the marker's not working right on this thing. Okay. So, but the main idea is to get the shaded region, you should be thinking, find the area of the circle and subtract the area of the square. Well, the circle shouldn't be hard. It's pi r squared, which is pi 12 squared. So that's the area of the circle. And then minus the area of the square is what we need. So we need the side length of the square. Now, again, there are lots of different ways of getting it. The one that I'm going to use, I'll use 45, 45, 90 theorem because that's the least, my guess is that's the one people are the least comfortable with. So if I draw a regular old 45, 45, 90 triangle here, you might remember the sides are 1, 1, and root 2. So the 1 goes with 12, the same way the root 2 goes with this side that I want, which I'll call x. So then cross multiply, x is 12 times root 2. Okay, so this is 12 root 2, and this is 12 root 2. So the area of the square here is going to be 12 root 2, length times width, or base times height, depending on how you want to think about it. So this is going to be 144 pi minus, and then the way you multiply roots that look like this, the outer parts you multiply together, and the inner parts you multiply together, and you get root 2 times root 2 is just regular 2. So it's 144 times 2. So this is going to turn into 144 pi minus 288, and then you can plug that into a calculator, and you end up with 164.389. 164.389, and the units, the original problem inches, so these are square inches. Okay, hope that helps a little bit, and I'll see you guys soon.